In this video, let's talk about how we can solve more problems and how we can solve these rational problems here. So I'm going to use the technique of LCD because that's going to expand the farthest. Might use a different color though, just I'm kind of worried that might not show up. So LCD, again, I'm going to use that method because it's going to expand to more problems. So T plus 10. Now, so this denominator is t, this is t plus 10, so our LCD has to be t times t plus 10. Okay, so what does the t plus 10 require? Well, it's going to require a t, so you have 3t, I can write that a little better, t plus 10 equals 4. Now, what's this t missing? It's missing the t plus 10. So I need a t plus 10 right there. All right. So both sides of the equation everyone is over the same denominator. They're over the LCD. So I'm going to multiply the whole equation by that denominator. And what's going to happen is it just totally reduces. Okay. So we find that we have 3t equals 4t plus 10. Okay. And we can kind of simplify that, but it's getting a lot easier. 4t plus, and that should be 40. Okay. Now I can start moving things around. I can subtract 3t on both sides. I can subtract 40 on both sides. And what does that give me? Negative 40 equals t. Okay. And so there is the answer. All right. Not so bad. I want to keep emphasizing that if you learn this technique of putting everything over the same denominator, it's going to make questions a lot easier, all right? Now, let's try this one. So we have solved for the equation we want to solve for x, and what would the LCD be? All right, so the LCD for this problem, I have x, 2x, and there's kind of like a silent 1 right there. So I would argue that the LCD is 2x. All right, well, what does this x need? It just needs a 2. So I need to go 2 times 9 becomes 2x. There you go. And what does this 2x need to become the LCD? Well, it doesn't need anything because it has everything already. Now this 1 here, this 1 needs the 2x, so we have negative 10 times 2x over 2x. Okay, now I can multiply both sides of the equation by the LCD, and the LCD will just reduce out now. Okay, so what do we get? Well, 2 times 9 is 18, plus 4 equals, and then negative 10 times 2x would be negative 20x. All right, so we have 18 plus 4, looks like 22 to me, negative 20x. Then I can divide both sides by negative 20. And it looks like we're going to find x equals negative 11 tenths when we reduce that fraction. All right, not too bad. Again, I'm using that idea of putting everyone over the LCD, and that way we can just get rid of all of the denominators. All right, let's keep going. So for this one, we want to solve for x, and it looks like I can do a little bit of factoring here. I can factor out a 3, I get x minus 3, and notice that that's also x minus 3. Negative 2 is kind of like over a silent 1, so let's do the LCD now. Well, we have 3, x minus 3, 1, and x minus 3, so I think the LCD has to be 3 times x minus 3. All right. Now, what does the 3x minus 9 need? It doesn't need anything. It already has everything going for it, so we'll just have 3x minus 3. I can write that a little better. There we go. Now that negative 2 over 1, it's going to need everything, so it's 2 times 3x minus 3, and that would be 3x minus 3. and that equals, and then here we have the x minus 3, 1 over x minus 3, and that's going to need the 3. So 1 times 3, and then 3x minus 3. Okay, now everything is over the same denominator. It's over the LCD. So I'm going to multiply the whole equation by the LCD, and they're all over the same denominator. So it reduces out, so we don't have to worry about denominators anymore. And I'm left with x minus 6 times x minus 3 equals 3. And now the problem is getting a lot easier, and we can really start simplifying things. So I have x minus 6x plus 18 equals 3. And that's looking like negative 5x plus 18 equals 3, and then negative 5x equals, we subtract the 18 on both sides, so we're going to get negative 15, and that implies that x must equal 3. Positive 3. Great. So that's not too bad. Yeah, so I still think that that's probably the best technique. Here, again, we can find the LCD. The LCD in this problem is going to be 8x minus 2. Okay, so what does the x minus 2 need? It needs 8, so 8x minus 2. This 2 over 8x minus 2, x minus 2. And now I can multiply the whole equation by 8x minus 2. And so it totally reduces out. So you get 8x equals 2x minus 4. Subtract the 2x on both sides, you get 6x equals negative 4. Divide both sides by negative 4, you get x equals, or I'm sorry, divide both sides by 6, you're going to get negative 2/3. Nice. Okay. So I think that should work for you. That should be fine. Okay, now for the next problem, it looks like I can factor out a 3 here. So I get x plus 1. I already have an x plus 1. I have a 2. So the LCD is going to be 2 times 3 times x plus 1. That way all of the pieces are represented. So the 4 here is going to need a 2 and a 3 on that. So 4 times 2 times 3 over 2 times 3x plus 1. Now the 2 that's under the 3 is going to need a 3x plus 1. So I have to go times 3x plus 1. And here we have the 3x plus 1, so the 8 needs to be multiplied by a 2. And we have 2 times 3x plus 1. Okay. Now everything is over the same denominator, so I can multiply by that denominator. Oh, that should have been, that already had a 2, excuse me. So you're probably wondering why I did that. So that already had a 2, so I just forgot to write it. So there we go. Now we have 4 times 2 is 8. 8 times 3 is 24. Yep, 24 minus 9 times x plus 1 equals 16. And it looks like I'm about to run out of time, but so we can solve this problem on the next video. But it looks like it will be much easier now with this technique. So I'll see you on the next video.